Continuing with 2.1, we're now dealing with one-step equations with multiplication or division. So the idea that we started to work with in the previous video was that, well, opposites attract. Mean people like nice people like mean people. And the way that we solve these one-step equations is by using opposites. So we'll soon see that if we have a term that's being multiplied, we work through that by using division to solve for our variable, whatever the variable might be. In this case, it's going to be a lot of x. And we also use this backwards, where if we see a term's being divided, we want to undo that using multiplication. So we'll see that these are used interchangeably. For this first problem, we have x over 5 equals 2. Well, what operation is going on here? What do you think? We have x, we have a fraction. What operation are we using here? Well, since we're dividing, we need to get rid of this by using multiplication. So I'm taking a look at this and I'm thinking, what is this term being divided by? How can I get rid of this fraction? Because I know I need to multiply both sides by some term. What term do you think would get rid of this fraction here? Hopefully you're saying 5, because if we multiply both sides by 5, and I'll show the work down here. So if we take 5 and we multiply that first fraction, x over 5, we can treat this as if it's 5 times x dividing by 5. And then can we cancel these 5s? Is that fair game? What do you think? Should be saying yes. 5s can cancel. This leaves us just with x. And then on the right side, if we take the product of 5 and 12, this would give us 60. So this is saying that x equals 60. And we can always check our work on this again if we plug back in. If we take, and I'll use the calculator for this, if we take 60 and we divide it by 5, that equals 12. So that was the way you can check. I'll give you a moment for the next one. So think opposites. What operation is going on? How can we undo that if we have 4x equals 22? Well, we see that 4 is multiplying with x, so we undo this using division. What should we be dividing both sides by to isolate x? 4 seems ideal, because if we do that, our 4's can cancel here. 22 over 4 is what we're left with. We can also simplify this further, because we know that 22 is 2 times 11. And 4 we could rewrite it as 2 times 2. So we could easily cancel our two terms, leaving us with x equals 11 halves. Our final answer. How do you think we could rewrite problem C? So this is 1/3 x, and you have a few ways you can approach this. Is this multiplication? Is this division? What do you think? So there are actually two ways you could go about this. How I'm going to solve this is using division. So although I could use a form of multiplication, and actually, yeah, I'm going to stick with division. So this is 1/3 times x. I'm going to use division on both sides for 1/3. So my 1/3 terms are going to cancel. This leaves us with x, and we now have this odd fraction of 5 dividing by negative 5 dividing by 1/3. How could we rewrite this? You might have to really channel your division skills on fractions, but we definitely saw a way we could rewrite this. And I'll give you a hint. It's using division of fractions. So this is dividing by 1/3, and the reason that we need to move this around is because we're working with fractions. So recall that if we're dividing with a fraction, we now switch to multiplication and we take the reciprocal of 1/3. So this would be 3 over 1. Eventually, if we simplify this, this is negative 15 over 1, which we can just rewrite to negative 15 for x. And that's our final answer. Takes some time to get there, but it's definitely manageable. I'll give you a moment for D. So we have x dividing by negative 9. How can we go about this? What operations being seen? What operation can we rewrite this with? Well, hopefully we see that we're dividing both sides. So now we would want to use multiplication to get rid of that. So we need to multiply both sides by our denominator. Well, what's in our denominator here? Should be saying negative 9. Multiply negative 9 on both sides. Our negative 9's on the right side, or sorry, the left side cancel. This leaves us with x, and then the product of 12 and negative 9, which we can then rewrite to negative 108. And that's x. We'll soon see in the next video that we deal with reciprocals. So kind of a mix of division, similar to what we saw in this problem, but we'll actually see an easier way that we could have solved those.